In this video, we're going to look at Chapter 8, Section C, on grouped discrete data. Remember from the last video that we looked at methods on how to organize and visually represent discrete data. Now those methods were useful when the data set contained only several numerical values. For instance, if I asked every student in the class how many children there were in their household, we might only come up with several possible answers. And if that were the case, we could use the methods that we learned in the last video. Sometimes, however, let's say there's a hardware store that wants to track how many people are visiting their store during lunchtime. So over 30 consecutive weekdays, they gather this data set. And you can see that there are a wide range of variables here. And so a normal tally frequency table or column graph wouldn't be very effective here because we have so many different values. So instead, we can group the data into like categories, which we call class intervals. For example, one class interval might be the values 10 to 19. So I would go through the data and I would circle or group all of the values that fall within that range. And we can see that I have 5. This makes the data much more manageable to work with, and if I do that for several different class intervals, I can come up with a new tally frequency table that looks like this. I still have my variable, but now the possible values are grouped into appropriate ranges. And I still have my tally chart using the same tick marks, but instead of only counting tens, now I'm counting all numbers between 10 and 19. And we have our frequency column as well, which is just the sum of all the tick marks. So in the second example, I have 9 instances that occur between 20 and 29. And so I have 9 hash marks, and I use the number 9 over here. Again, this allows me to quickly total the number of data points that I have, and I can see which class interval occurs the most. And in this case, it's 30 to 39. Now remember, the mode is the data value that occurs most often. So in this case, we have several data values in the group 30 to 39. So instead, we'll call this the modal class. So this is the class interval that occurs the most in the data set. Another way to visually represent these types of data is to use a stem and leaf plot. A stem and leaf plot, which is sometimes just called a stem plot, is a way to visually represent grouped data, usually for small data sets, and unlike the tally frequency table, we actually get to see all of the data points. Let's take a look at the raw data again from the hardware store. Notice that all of the values are 2 digits, and that the first digit ranges from 1 to 5. These first digits form our stems. So the first digit could be 1, 2, 3, 4, or 5. Then the second digits form our leaves. And we can go through the entire data set and write down all of the data values in this way. So for the first data value of 37, I go to the 3 row and I write a 7 over here and then a comma. The next number is 30, and so the first digit is 3 and the second digit is 0. And I can do this for all of the data points. And so this gives us a way to quickly see all of the data points, but also to group them into class intervals. The finished stem and leaf plot will look something like this. Notice all 30 of the data values are included, and again we can quickly see that the values between 30 and 39 are the modal class. These are the values that occur the most often. But notice that the numbers in these rows aren't really in order. And there are some statistical analyses that we would like to do that would be a lot quicker if we could order the data. So generally, once we've written the data in a stem leaf plot, the raw data, we then order each row from smallest to greatest. And that finished organized stem leaf plot would look like this. Notice I have all of the same data points, but now they're organized. And you'll see why that's helpful in a little bit. But there are two things that we can notice right away. One is the minimum value of the data, which in this case is 13, and the maximum value of the data, which is 54. And, like I said earlier, we know the modal class. Let's take a look at an example problem. This is problem number 3 in exercise 8C from your textbook. We're given an ordered stem and leaf plot, which is nice, so we don't have to do a lot of the work. And we're asked to find 5 things: the minimum value, the max value, the number of data with a value greater than 25, the number of data with a value of at least 40, and the percentage of the data which is less than 15. Well, the minimum value is the first value in the stem and leaf plot, and we can see that it's simply 1, and the maximum value is 43. The number of data with a value greater than 25 we can find by first finding 25 and then counting all of the digits that occur after 25. So we have 6, 8, 9, that's 3, 4, 5, 6, 7, 8, 9, 10 data points that are greater than 25. The next problem is at least 40. So we don't have a 40, we don't have a 40 on the stem and leaf plot. We start with 43 in this class interval, and so there's only one data value that is at least 40. And then the last question, to find the percentage of the data which is less than 15, we first need to know how many data points there are. And we do that by counting up the digits in each row. So in the first row I have 3, in the second row I have 7, and in the next row I have 11, and then I have 6, and then 1. So if I add all those up, I get 28. And then I simply need to count the number of data points which are less than 15. Again, there's no 15, but I can draw a little line here, noting where 15 would be, and then count the values that are less than 15. So I have 6 values. So to find the percentage, I divide 6 by the total number of 28 and multiply by 100 to get the percentage, and I'm going to get 21.4%.